Inflammation is a topic that's very, very commonly discussed in pathology classes and immunology classes, and rightfully so, because it's one of the first things to occur that tells your body that something is wrong or it has been injured in a way. So it's definitely very important to discuss, which is what we're going to do throughout this video. So, to begin with inflammation, and this is a picture that I really, really just enjoy looking at. I just think it's a beautiful picture, but really, there are the 5 signs. They're known as the 5 cardinal signs of inflammation, and I've written them down in their Latin forms, but if you look at the picture, you can see that they have them in their English forms as well. But basically, you have rubor, which is redness, dolor, which is pain, calor, which is heat, tumor, which is swelling, and then, of course, you have loss of function. So those are the 5 cardinal signs of inflammation. If you know the 4 Latin and then the one that's just the random loss of function, you're good to go. Okay, so the function of inflammation is really to limit the spread of pathogens, to destroy them, remove debris of damaged tissue, and that says initial tissue repair. That's a typo. It should be initiate tissue repair. All right, it initiates tissue repair, and it's very important that once inflammation has started, it's very important to stop it as well, and that's a whole other process of its own that's pretty complicated, and we won't be getting into it in this video, because this is really just to brush upon inflammation very generally. It increases capillary permeability. Now, what do we mean by that? Increasing capillary permeability, first of all, means vasodilation. So you're dilating the blood vessel in order to increase the permeability of the blood vessel, so white blood cells can rush into the blood vessel or whatever the area, wherever it is that they are needed. So it's crucial to increase your capillary permeability for that reason. It increases blood supply, all right, because you need the white blood cells. And of course, it's going to increase the migration of white blood cells to that area because it's increasing the above 2 points. So, time for a pop quiz. Which white blood cells are the first to arrive at the site of inflammation? And we really haven't discussed this at all in this video, but take a good guess. So I'm going to show you the options, and you can go ahead and pause this video right now and answer it on your own, and then I'll reveal the answer. So the correct answer here is C. Neutrophils are the first white blood cells to arrive at the site of inflammation. And also, just a little fun fact to throw in here, pus is known as a cluster of neutrophils. That's what pus is, so just for your knowledge. Now, inflammation is going to activate very important systems in the body. The first being the complement system, which is really sort of kind of like a cascade reaction that's composed of enzymes and proteins. It's going to activate natural killer cell activity, which is a very important part of our innate immune system. Natural killer cells are types of lymphocytes that are exclusive to innate immunity. They are going to increase cytokine activity, and of course they're going to increase the temperature, right? Because that was one of the cardinal signs. Heat was one of the cardinal signs of inflammation. Now, this is a clinical pearl, which means that this is very important for you to recognize, especially if you're a PA student and you're prepping for your PANCE or recertification exam. This is a clinical pearls, and clinical pearls are gold. All right, they're gold. So the first clinical pearl is that steroids and other anti-inflammatory agents, such as NSAIDs, an example of an NSAID would be an ibuprofen, or steroids, such as prednisone, are known to decrease immune function. In fact, if a patient is prescribed a steroid, and if it's going to be used long term, they are actually at risk for becoming immunocompromised, because steroids, one of the major adverse effects of steroids are a decreased immune function. So just keep that in mind, just to emphasize a little bit more on the clinic pearl. Now, fever is another very important topic when we talk about inflammation. And fever is really a widespread systemic response that's going to promote cytokine activity. And it's important. It's not a bad thing if you think about it. Fever is actually a pretty good thing. It's important because it's going to increase your metabolic rate. And what happens? Basic chemistry, guys. What happens when you increase your metabolic rate? Well, when you have a reaction, what's happening? If you're increasing the rate of the reaction, things are happening faster, right, and better. So fever is really a spike in your temperature, and it's going to increase the metabolic rate. It's going to increase tissue repair, and it's going to inhibit microbial reproduction. So fever is really a good response to some extent, and it's a systemic response because of the communication going on in the body. Now, another clinical pearl related to fever is that fever does not always mean infection, all right? Clearly, we're talking about inflammation here. So fever can most definitely mean inflammation, autoimmune disease, or it can even be induced by drugs. So if a patient comes in, presents with fever, don't always jump to the conclusion that they're infected. Most likely they are, but it can also mean these other underlying causes, and the star being inflammation. Now, cytokines are protein hormones that act as regulatory mediators by stimulating inflammation and enhancing phagocytosis. Now, if you really look at articles online or even textbooks, there's really not a lot known about these. There's really not much known about cytokines at all, and their function is really just very briefly known. They're sort of kind of like a medical mystery, but whatever we do know about them is that they're very, very important. Why? Because they're the main communication mechanism in the body. And these are responsible for the fever, for the systemic reactions that go on in the body along with inflammation. So just know that these are very important in stimulating inflammation and killing your microbes via phagocytosis. And an example of this is the flu. All right, the flu is found in your respiratory tract. It's exclusive to your respiratory tract. You don't get the flu in your brain. You don't get the flu in your most flus you don't get in your GI tract. You don't get it in your in your endocrine system or anything. But when you have the flu, or when you're infected by the flu virus and it's your respiratory system that's infected, you get a fever. And that is a systemic response to something that is localized, and that credit we can give to our handy-dandy cytokines because they are responsible for this widespread communication that's going on in the body, allowing inflammation to occur. Now, antimicrobial proteins, you have acute phase response, and this is something that consists of high levels of plasma proteins, all right? High levels of proteins in the plasma, in the blood. An example of this is the C-reactive proteins that are produced by the liver in response to cytokines. So interleukin-1, interleukin-6, and tumor necrosis factor, also known as TNF or alpha TNF. These are produced by macrophages after exposure, and again, they're communication mechanisms, guys. The key here is communication. Now, defensins are positively charged peptides that create pores in the bacterial membranes. They're defending you by creating pores in the bacterial membranes, and these are located in the GI and respiratory tracts, all right? So in your GI system and in your respiratory system, your stomach, your lungs. Now, interference is something I'm going to talk about this in not just this video, in a bunch of videos, because they're just so important. But really, the example that I always give out whenever I talk about interference is, imagine that you're in a building and there's a fire in that building that started in your apartment. And you run out of your apartment and you knock on every single door in the building to warn people that there's a fire and you want to escape before it gets to you. Well, that's what interferon does. Interferon is the knocker. It's going to knock on every single cell or any single relevant cell in the body, and it's going to warn them that, hey guys, there's a virus in the bloodstream, so you better protect yourself, all right? So again, this plays a very major role in communication. Remember, communication is a key. So these are polypeptides secreted by cells that have been invaded by viruses, right? These cells are going to send out these polypeptides, and they're going to say, go warn the other people. They diffuse to neighboring cells, and they prevent viruses from attacking them, and they inhibit viral replication. And of course, they're going to activate your natural killer cells, because what do your natural killer cells do? They're part of innate immunity. They naturally kill. And they're going to activate macrophages. Now, the complement system is another very, very important concept when it comes to inflammation. As you can notice, everything is important, so just make sure that you have a grasp of everything. This is a complex set of enzymes and proteins that are formed by the liver that form a cascade type of a reaction to destroy microbes, allografts, or tumor cells. And they do this by damaging their membrane, generating mediators of inflammation, or enhancing phagocytosis and cell activation. Now, this is quite a tongue twister, guys. APOBEC3G. All right, try to say that 3 times without stopping. This is known as a polypoprotein B RNA editing enzyme, and really the major star you need to know here is that it's a defense against retroviral infection. All right, retroviral infection. What's the famous one? HIV. All right, that's a retroviral infection. And this is going to cause a hypermutation, hyper meaning high or excessive mutation. So it's going to cause excessive mutations in retroviral DNA. Macrophages. They may be normal or they may be inflammatory. And you have your normal macrophages found in your Kupffer cells, which are found in the liver, alveolar found in the lungs, right? Your alveoli in the lungs, so alveolar referring to the lungs, and your mesengial, I never know how to pronounce that word, so pardon me, but your mesengial macrophages, which are found in your kidney. And then you have your free fixed macrophages in your lymph nodes, your spleen, and your bone marrow. And you have histiocytes and Langerhans cells in your connective tissue. Remember, Langerhans cells were also known as dendritic cells, right? They're found in the mucous membranes, and they pick up debris or garbage, remember? Pleural and peritoneal macrophages. So pleural referring to the lungs, peritoneal referring to the peritoneum. Got to use those context clues, right? And, of course, microglial cells you definitely must have heard of in anatomy, which are found in your CNS, or your central nervous system. So, leukocyte deployment. Now, you have communication throughout the body. It's important to do something about it, right? You have 2 countries. One of them has declared war on the other. One of them being your body, the other being the virus. The virus has declared war onto your body. Your body knows that your virus has declared a war onto it. Now you got to do something, right? You have to send out those soldiers. So leukocyte deployment is really at sites of inflammation. Chemical messengers are released by basophils, mast cells. So you're really starting to get to work. You're really starting to pick up your fight and pull up your socks, right? And this occurs by margination, diapedesis, and chemotaxis. And we're going to get into these. So what is margination? This is where chemical messengers are going to line up and they're going to adhere to the epithelial wall of the blood vessel. So basically, all your soldiers are lining up, all right? And think of your blood vessel. Think of 2 walls, and your blood vessel is between those 2 walls, right? And your chemical messengers, or your soldiers, are really lining up against those walls. Now, this is a good thing because it starts off the process. But the only star you need to know here is that this is going to give you, or it can give you, a low or false white blood cell count. All right. Therefore, acute infection can give a low white blood cell count. So if you happen to, and this honestly in the clinical setting doesn't happen too often, it's really a rare occasion. But if it does happen, it's normal, and this can give you a false white blood cell count, because what's going on? If you're going out to look for all your soldiers in the field and they're all lined up against the walls, you can't see them, right? So you're going to think that there are no soldiers there. That's exactly what happens. So when you draw the blood of a patient and they're in the margination phase, which is, again, I said very rare, but if it does happen by chance, just so you know, and you're drawing blood, you might get a low white blood cell count, and it's because these chemical messengers are lining up and sticking to the walls of the blood vessel. So it seems like the person doesn't have enough white blood cells, but after about a week or even a couple of days after you check and you redraw the blood, you should be able to find those white blood cells because they were just hiding. Now the next step is diapedesis, which is where it's essentially just squeezing. So these chemical messengers are squeezing between these endothelial cells to enter the interstitial space. So think of your soldiers now squeezing in between those tight walls to enter the battlefield, right? So they're squeezing between to enter the interstitial space. And of course, now you have chemotaxis. Now, think of your soldiers, they've entered the battlefield. They're not just going to, go and attack random empty places. They're going to be attracted to a certain site where they can find the opposite, the opposing soldiers or the opposing army, if you will, right? So that's what chemotaxis is. They are attracted to inflammatory chemicals that are released at the site of inflammation. So inflammation, or the site of inflammation, is going to release these chemicals, and these mediators are going to be attracted to those, and they're going to move in that direction, right? Because there's no point in attacking the empty field, right? You want to attack so you can kill. And of course, this is going to end in phagocytosis. So just think your soldiers have now attacked. They found the opposing team. They found the army. All right. And now they're basically just going to eat them up. All right. This is getting very dark here, but just stick with me. All right. Desperate measures. So yeah, they're basically just going to engulf the opposing army, right? So it's going to end in phagocytosis. So your chemical messengers and your major phagocytizing cells are your neutrophils, right? They phagocytize your natural killer cells. So they are going to end up they're going to hunt them. They're going to find them. Once margination, diapedesis, and chemotaxis has occurred, inflammation will end in phagocytosis. And that, my friends, is it. So if you have any further questions, I know this was a very brief touch up sort of on inflammation. If you do have further questions, you can definitely contact me. My email address is below. It's provided for you. And I have I will have a bunch of videos in my immunology and a bunch of other playlists, so you can feel free to check those out. And if this was helpful, please subscribe. And I hope whatever you're studying for, your exams or whatever, I hope that my video helped a little bit, or it helped clear up a couple of things.